I am Bolívar Erazo. I'm from Ecuador. I'm the director of the National Institute of Meteorology and Hydrology, INAMHI. So I will present some improving in monitoring and early warnings in Ecuador, some platforms, and a little project with AI developments. Next, please. So it's important to start with the context of Ecuador to understand what happens. We have a really complex climatology in Ecuador. We are in the middle of the tropical region. So we are influenced by, for example, in general, the ITCC, the Intertropical Convergence Zones. That is a convective region that creates a lot of convective clouds, and this modulate the seasonal rainfall. Also, the interannual rainfall are influenced by El Niño, the two variants, El Niño and La Niña. That depends if the ocean is hot or cold. And also another important system is the humidity from the Amazon basin. So in general, we are in a really complex context in Ecuador. So it's, thank you. So it's quite hard to monitoring and be updated about with the conditions in Ecuador. Okay, so we are also crossed by the Andes range from the north to south in the middle of the country. So the Andes range from 0 to 6,200 meters. So it's quite a huge range, and it configures the main regions, the coast, the Andes, and the Amazon region. We have the Galapagos Island also. So do this Andes range. So we have also a vast drainage network, a lot of rivers configured by the Andes range. So it's a reality also that we are in we have the global climate change effects. So we are in a warmer planet. So we also have a lot of changes in the temperature anomalies that also are related with changes in precipitation patterns. So in consequence, we have also an increase in the frequency and intensity of extreme events like droughts and floods. It's also a reality for Ecuador that we have in the past 3 years an increase in the frequency of extreme events. For example, we have in Ecuador this tool. This tool is the weather warnings that we publish on our social network for the next 4 or 5 days. And for example, these are the data from the last 3 years. We have in average 10 more meteorological warnings by year. So this indicates that the frequency of extreme events is increasing and probably will continue to rise. And this is the impacts of that extreme events. For example, the last year, on 2024, we have really heavy droughts in Ecuador that produce power outages that impacts human lives and the economy. And in this year, in the beginning of this year, 2025, we have the other extreme and the heavy rainfall that produces floodings in Ecuador. So it's a reality also for the globe and for Ecuador, the extreme events. So this is the, and that's why the importance of early warning systems. For example, this is the tool that I mentioned, is the meteorological warnings. This is always always on our media network, and these alerts about the levels of heavy rainfall, like medium, high, and really high alert in the territory for the next 4 or 5 days. We analyze, of course, a lot of models and ground data to do this analysis. So This is the map of alert for the general period and the specific dates with the more important events and a description of what could happen by regions. These meteorological alerts are also open and available over the CAP platform, the Common Alerting Protocol. So it's always here in the CAP. And these meteorological alerts are also communicated in coordination with the Secretary of Risk Management in Ecuador by text message, especially over the regions that are in a really high alert. So the next step, more than the meteorological alerts, is the implementation of early warnings. So as Ecuador, we are Ecuador is part of this initiative, Early Warnings for All. We are part along with 7 countries. So especially we will implement the second pillar that are managed by the WMO and also INAMHI in Ecuador. So we will have some funds to improve our detection, observation, monitoring, and forecasting in Ecuador. So this is good news also. This project is already approved by the GCF, the Green Climate Fund. Of course, early warnings requires also baseline information. It's not only about models and tools. We need the ground information, observations. So we already work in 2 main axes, the reactivation to reactivity monitoring, and also develop some integration platforms. This first, about the reactivating hydrometeorological monitoring. We have some resources, and we activated the last 3 years a representative network with 98 hydrometeorological stations. The majority, the green points are the automatic ones, and the red points are the conventional stations. We already work also in the integration of external networks. For example, the case of Quito, the capital of Ecuador. Quito have an interesting local network with 47 stations. So we already integrate these stations in the national database. And with Quito, if we have the access to local information, we can also test, for example, local models, local modelation with data assimilation. It's quite a negotiation with Quito. If we gave me more data, we can also test some local modelation. And related with the second axis, we already developed some interesting integration platform like INAMHI-GEOGLOWS. INAMHI-GEOGLOWS is like a customizable platform for Ecuador, and we can access to a lot of products. For example, our numerical modeling forecast with WRF. We can activate this here in the Data Explorer app. We can also activate some satellite products, estimations of rainfall like IMER, Persian. We can also activate wildfire hotspots that we obtain from MODIS channels, for example. We can activate also some predefined layers or also upload some shape files in this platform. So in this platform, we can really mix the data to analyze the meteorological conditions. We can also activate our meteorological alerts, and we can also activate all the channels from GOES. So it's a good platform to do a good analyze. We can also do some interesting data related with hydrology. This is the second app, Hydro Viewer. This is the outputs of hydrological modelization through the GeoGLOWS global model. So we can have the the historical modelization over 2,200 rivers in Ecuador. And we can also do the hydrological forecast for the future 15 days. Of course, this is modelization, but we have another app that calls historical validation tool to correct the modelized bias with the hydrological observations. We can also mix the meteorology and hydrology. We can see the alerts, the automatic hydrological alerts mixed with the meteorological alerts. So we can analyze meteorology and hydrology also. In this platform, INAMHI-GEOGLOWS, it's also integrate the some products from WMO initiatives like a flash flood guidance system. So we can activate products as average soil moisture, rainfall required for flooding, and rainfall forecast, and other information from FFGS of WMO. This platform, INAMHI-GEOGLOWS, can also create an automatical report related with rainfall, temperatures, hydrology, etc. This is automatic, but of course, this is edited by an expert analysis because all cannot be completely automatically. This tool, INAMHI-GEOGLOWS, is also used by the National Secretary of Disaster Risk Management. So they also have access to the meteorological and hydrological tools through two main offices in Quito and Guayaquil, and through 18 regional offices. And they also have access to these maps. Of course, with our support, with our technical support. And this is some developments related with early warnings, with artificial intelligence. We have a little project with not a lot of money, only $28,000 to develop an interesting tool that mixes the satellite channels with a local network that are trained when some conditions viewed by the satellite produce a heavy rainfall. These models are trained with artificial intelligence. So we trained with some years this algorithm, and then we can use this algorithm with deep learning based nowcast for detecting convective storm development. So this is in train. We will finish the next month. So it will be a short project that will be really interesting to apply artificial intelligence in mix some GOES channels with local stations. We also work beyond the technical aspects. We also work in some core issues. When I started my administration at INAMHI, we found the INAMHI at the level 2 because that are the qualification range of WMO. So we already advanced one scale, one step from 2 to 3, according to this country hydrometric diagnostic. So the blue line are the qualification of 2021, and are now the red line is our qualification through the 10 components of WMO in 2024. We have some problems with permanent resources. That is the reality of South America, and this was an error of the evaluation of 2021 because we need also to start to send information through the GBON platform. But in the short term, we will do that. And of course, we will be from 1 to 3 because as I mentioned, in 2021 was an error because INAMI sent only information from conventional stations, but it's important to meet the requirements of GBON. The automatic meteorological stations need to send the information through GBON each hour and permanently 24 hours. So in general, we have one more level in according the country hydromet diagnostic from WMO. Of course, there are still some challenges to work on. Some challenges, some really big challenges, like institutional restructuring. We are working on that because at INAMI we have a really ancient structure of personnel, and their responsibilities are not really clear. So we are working on that in a complete institutional restructuration. The financial sustainability, not solely reliant on public funding, because this is quite difficult to depend completely from public resources. But we already work on that. We have a theoretical study by the IDB. So we are developing theory in paper, in a document, an hybrid funding procedure and mechanism, but it is in paper, and we will need to pass from the theory to the practice. A specific financial mechanism for observation and monitoring, because observation and monitoring is the expensive item in all med services. So it's important to find an alternative financial mechanism for this. We do this work with international cooperation, really well coordinated with local investments, local public investments, but we need really the permanent resources, by the way. Technological infrastructure modernization is also important. We already do some work on that. We already invest around $1 million to a technological modernization of processus servers also. Staff training, it is important also. Some staff training we do through WMO programs. User-centered services, it's also important. For example, INAMHI-GEOGLOWS is quite a platform that we develop, we develop user-centered services, but user-centered, I mean public users, like the National Risk Secretary. And international and regional collaboration. It's also another challenge to work on at INAMI. To finish, these are some key conclusions. For example, a cross-cutting conclusion. INAMI's project, as well as those received through cooperation, are executed efficiently and with coordination, avoiding duplication efforts and being strategically focused on institutional development. That was really important because when we show to the cooperation and to the public investments that we develop projects very well coordinated and without duplications, we have a better image, so we can access to more resources. INAMI has made significant progress with limited resources, sustaining active monitoring and existing services through investment projects and international cooperation. So we really do a lot with less. To further enhance its maturity level of INAMI, will need increase the public funding or a financial mechanism aligned with Ecuadorian regulations to ensure a sustained growth and long-term sustainability. This is important because public resources are always limited, so it's important to start to apply theoretical studies that we develop and and we have clear in theory and an alternative financial mechanism, but it's important to apply this from the theory to the practice. For us, it is important to find an alternative financial mechanism according with Ecuadorian regulations to have permanent money. Extreme meteorological and hydrological events are becoming increasingly frequently and intensity and are becoming increasingly in frequency and intensity, resulting in significant loss of life, property, and infrastructure. Accurately quantifying these hydrometeorological losses in Ecuador could provide a strong evidence-based support to justify increased public investment in INAMHI. This is important because in general, we have data that if we invest $1 in meteorological service, we gain between $6 and $10. But this is a general and global data. It is important to have a specific data from Ecuador of how much we gain if we invest in meteorological and hydrological service. And with this data, we can ask for the financial minister for more resources. So it's really important to do that at the Met services, especially in INAMHI. And that's all. Thank you for your attention. Gracias por su atención en Spanish. Thank you very much.
Thank you for your presentation. How could you tell us something about how the INAMHI-GEOGLOWS platform was developed? How have you implemented that? That looks like a really nice platform to bring in the information.
You mean you want to explain the processes, the
well,
implementation
yeah,
process?
I guess briefly how you came up with that platform.
We start to work with GeoGlows. GeoGlows is a global initiative financed by USAID, Servir Amazonia, and some US programs. But the original platform is quite a general platform that can be applied everywhere. The work at INAMHI was use the main code, the general code, to customize for the reality of Ecuador. So introduce the river network, the national river network, doing programming through Python code to integrate the GOES channels, cut the political limits of Ecuador, increase more options to upload, for example, shape files, precipitation estimation products like Persian, IMERG, etc. So we use the general and global platform to do our work, really emphasize on Ecuador necessities. That was the work. So that was financed by United States with the work of our technicians also, and with a local NGO of Ecuador. So the GeoGlows platform have an open code. The open code are available over GitHub platform. So we have a manual of the code also. I think it's a good example of adaptation of a global platform to a local, to a country. And it can be developed a lot, and we can develop more code to continue improve this platform.
Hi, thank you. It's really great to see all the improvements and efforts being put. You mentioned that you are one of those early warnings for all countries, priority country. Is there any way that you can transfer your lessons learned to other members of RA3 or RA4 from this process, like the GeoGlows? David took my first question in terms of what scripts you have already developed to ingest the river forecast and the river monitoring networks, for example? Is it possible to get together with, say, the regional office of the Americas to create a webinar or an expert team or something, a smaller short-term group or some kind of capacity development that would allow other members to take advantage of what you've already learned?
Yeah. Of course, we can do that. Count on that. We can planify a webinar or something like that to share more details about our experience with GeoGlows. Yeah, of course, we can do that with pleasure with our technicians, or even we can invite the global group of GeoGlows to do a complete webinar to explain all the details about that. Thank you very much.